Walk through any international airport, and within minutes, you'll notice something that's almost hiding in plain sight. Thousands of people move past one another. Some have skin so light it seems to catch every beam of light in the room. Others carry skin dark enough to thrive beneath a blazing midday sun. Black hair, brown hair, blonde hair, red hair. Faces that look completely different and yet belong to the same species. That's the strange part. A child will often notice it before an adult does. They look around, take everything in, and ask a question so simple that most of us forget how remarkable it is. Why don't humans all look the same? Honestly, that's a fair question. Look at wolves. Look at zebras. Look at penguins. Members of the same species usually stay within a fairly narrow visual range. Humans don't. Humans carry an entire spectrum. So why? Was it random chance? Was it beauty? Or was something much bigger happening? Imagine that every shade of skin and every strand of hair is carrying a message from the distant past. Not decoration, information. Not fashion, survival. The colors we see today are clues left behind by generation after generation trying to stay alive. And that's where the mystery gets deeper. Researchers estimate that all modern humans share a relatively recent common ancestry, which means if we started from roughly the same roots, how did we end up looking so different from one another? At first, the answer seems obvious. Maybe skin color is just appearance. Maybe hair color is just appearance. Maybe it's all cosmetic. But evolution rarely spends energy on something for no reason. If a trait keeps appearing, keeps spreading, and keeps surviving across generations, something is usually applying pressure. Something is shaping it. So what was shaping us? Imagine an invisible force touching every human who has ever lived. Not a predator, not a disease, not an enemy. Light. The same sunlight warming your skin right now has been quietly shaping human bodies for hundreds of thousands of years. Wait, sunlight? How could sunlight possibly change the appearance of an entire species? Because sunlight isn't the same everywhere. Near the equator, too much sunlight creates one challenge. Far from the equator, too little creates another. One star, two completely opposite problems, and human color became part of the solution. To understand where all of this began, we have to travel back somewhere between 1.2 and 1.8 million years, back to East Africa. Fossil records suggest that one of our ancestors, Homo erectus, was undergoing a change that would eventually affect the appearance of every person alive today. Oddly enough, the story doesn't start with skin. It starts with hair, or more accurately, the loss of it. As these early humans spent more time moving across hot environments and tracking food over long distances, thick body fur became less useful. Bodies produce heat. Muscles produce heat. Movement produces heat. And too much heat is dangerous. So evolution began favoring a different strategy. Sweat. Humans became exceptional at cooling themselves. By sweating across large areas of exposed skin, we could dump heat into the environment more efficiently than most mammals. But every advantage comes with a cost. The moment body hair disappeared, something else became exposed. Skin. For the first time, human skin faced the sun directly. And that's where one of the most important characters in this story steps onto the stage. Melanin. Most people rarely think about it. Yet melanin may be one of the most important molecules in human history. A built-in shield, a filter, a biological umbrella. As our ancestors spread into different regions of the world, melanin began tracing an invisible map across the planet. A map made of sunlight. And the moment bare human skin met the sun, the story of human color truly began. Imagine living near the equator hundreds of thousands of years ago. The sun hangs high overhead almost every day of the year. The ground radiates heat. The air seems to shimmer. Shade isn't comfort, it's valuable. For the humans living there, sunlight wasn't simply something that helped them see. It was a constant evolutionary pressure. Researchers believe one of the biggest risks involved a nutrient called folate. Folate plays a crucial role in cell division, fertility, and healthy fetal development. Excessive ultraviolet radiation can damage folate levels in the body, and that's a serious problem. No folate, no healthy reproduction, no healthy future generations. Suddenly, darker skin starts making perfect sense. Higher concentrations of melanin help absorb and scatter ultraviolet radiation before it can cause as much damage. Not beauty, protection. Not appearance, survival. Not style, biology. Generation after generation, individuals whose skin handled intense sunlight more effectively were more likely to leave descendants. The change wasn't dramatic. It wasn't sudden. It accumulated slowly. One generation, then another, then hundreds more, then thousands. When you look at populations whose ancestors remained near the equator for long periods, you're looking at the result of one of evolution's longest-running negotiations with sunlight. And here's the part people often miss. Dark skin was never a flaw. Dark skin was never a compromise. Dark skin was biological armor. The body remembers what the environment demands. And under the equatorial sun, protection was exactly what the environment demanded. Then humans began moving across coastlines, across mountains, across vast stretches of land. Eventually, some groups pushed into Europe and northern Asia. And suddenly, the rules changed. The sunlight that flooded equatorial Africa became weaker. Winters grew longer. Cloud cover lingered. For months at a time, the amount of ultraviolet radiation available was only a fraction of what existed closer to the equator. The old solution was now creating a new challenge. Because humans need sunlight to help produce vitamin D. Vitamin D supports bone growth, immune function, and overall health. Too little can carry serious consequences. This time, the problem had flipped completely. Near the equator, the danger was too much ultraviolet radiation. Far to the north, the danger was too little. Same species, same sun, opposite challenge. Over thousands of generations, genetic variants associated with lighter skin gradually became more common in certain northern populations. Lighter skin allowed available ultraviolet radiation to penetrate more effectively, helping maintain vitamin D production where sunlight was limited. Evolution wasn't playing favorites. It was solving problems. Different location. Different pressure. Different answer. A simple question might be this: why didn't humans just stay the same color everywhere? Because nature rarely rewards staying the same. It rewards fit. The environment writes the test. Evolution writes the answer. And in northern regions, that answer slowly became lighter skin. But skin color is only half the story. Hair turns out to be even stranger. After the last ice ages, certain human populations in Europe began displaying an unusual burst of variation. Blonde hair, red hair, light brown hair, dark brown hair, differences that remain relatively uncommon across humanity as a whole. So why did this happen? The truth is, researchers are still debating it. Several possibilities have been proposed. Small populations can amplify rare genetic variants through chance alone. Migration can carry unusual traits into new regions. Sexual selection may influence which traits become attractive and therefore more likely to persist. Chance, movement, preference. Three forces pulling at the same thread, and no single explanation completely solves the puzzle. Take the MC1R gene, often linked to red hair and other pigmentation differences. Its evolutionary history appears to follow a somewhat different path from the genes associated with skin color adaptation. And that opens the door to a fascinating possibility. Some human colors may not have survived because they were necessary. Some may have survived because humans pay attention to difference. Because humans remember difference. Because humans are drawn to difference. Wait, that's a strange twist, isn't it? For most of this story, color was about surviving the environment. Now, color may also be about attracting attention within it. Survival and attraction. Necessity and preference. Nature and culture. And if you're still with me, subscribe, because the strangest part of this story isn't why colors appeared. It's why they survived. And that question takes us somewhere even deeper. But before we get too comfortable with this explanation, there's something important we need to address. Evolutionary stories can sound neat, sometimes a little too neat, and nature almost never behaves that way. Nature loves exceptions. If sunlight alone explained everything, then we'd expect every population living near the equator to have the darkest skin imaginable. We'd also expect every population living in cold northern regions to have the lightest skin. But reality refuses to be that simple. Take the Inuit of the Arctic. For thousands of years, they lived in regions where sunlight was limited for much of the year. By the logic we've been following, lighter skin might seem inevitable. Yet researchers point out that traditional Inuit diets contained large amounts of fish, marine mammals, and other foods rich in vitamin D. In other words, the body found another way. Not through sunlight. Through food. Wait, doesn't that undermine everything we've talked about? Actually, it does the opposite. It only cares that the problem gets solved. Different paths, same destination. Different tools, same outcome. The goal stays, the method changes. And that might be one of evolution's deepest rules. So let's return to the question that started this entire journey. Why do humans have different skin colors? Why do humans have different hair colors? The simplest answer is race. The simplest answer is appearance. The simplest answer is that people just look different. But simple answers aren't always wrong because they're false. Sometimes they're wrong because they're incomplete. The deeper story begins beneath the surface. Skin color was never only about skin. Hair color was never only about hair. These traits are records. Records of sunlight. Records of geography. Records of nutrition. Records of migration. Imagine taking a map of Earth and connecting climate, food, movement, and survival with invisible threads. Now imagine those threads being written directly onto human bodies across thousands of generations. That's what you're seeing. The darker skin that helped protect folate beneath intense equatorial sunlight. The lighter skin that made vitamin D production easier in regions where sunlight was scarce. The unusual hair and eye colors that emerged through migration, isolation, chance, and human preference. At first, they look like separate stories. They're not. They're pieces of the same map. One species, one planet, endlessly adapting to new conditions. Your body is a history book written in biology. Not categories, adaptations. Not labels, solutions. Not division, survival. And once you see that, human color stops looking random. It starts looking like evidence. Now bring all of this a little closer. Closer than Africa. Closer than Europe. Closer than ancient migrations. Think about yourself. Look at your arm. Look at your hair. Think about the faces staring back from old family photographs. Most people see ordinary features. Evolution sees a survival story. Imagine a chain stretching backward through time. Parents, children, mothers, fathers. Harsh winters, scorching summers. Journeys into unfamiliar landscapes. Generations facing challenges they couldn't fully understand. And somehow, through all of it, the chain never broke. Every pigment cell in your body exists because countless ancestors survived long enough to pass that story forward. Think about that. The shade of your skin isn't just yours. The color of your hair isn't just yours. The traits you inherited aren't just yours. They're messages, fragments of environments you may never experience. Clues from places your ancestors once called home. Proof. Because every generation faced a test, and every generation that led to you found a way through it. The body remembers what the ancestors survived. When you look into a mirror, you're not looking at a random collection of features. You're looking at evidence. Evidence that your ancestors succeeded. Now think back to that international airport. People are still moving past one another beneath the same roof. Thousands of strangers. Thousands of different faces. At the beginning of this story, the differences were the first thing we noticed. Different skin, different hair, different features. But now something else stands out. Every color is a chapter from the same journey. The darker skin shaped beneath powerful equatorial sunlight. The lighter skin shaped beneath weaker northern skies. The blonde hair, the red hair, and countless other variations carried forward through migration, adaptation, chance, and time. Different outcomes, same process. Different colors, one species. Imagine tracing every human family line backward, across deserts, across forests, across grasslands, across ice. For a while, the paths spread outward in different directions. Then they begin to converge. Further back, further back, further back, until they point toward the same ancestral homeland. Wait, isn't that the strangest part of all? The traits that seem to separate us often reveal how deeply connected we are. Not division, adaptation. Not distance, connection. Not different stories, one story. Researchers estimate that life on Earth has existed for more than 4 billion years.
Across that immense stretch of time, millions of species have appeared and disappeared. Yet only one species carries on its body a living map of ancient migrations spanning an entire planet.
And that diversity doesn't pull us apart. It reminds us where we came from. The deeper you look at difference, the more you find connection. We carry sunlight from different worlds.
Subscribe.